Very soon.
Okay.
Right, you're gonna be fed.
Yeah. Hello, welcome. Welcome to Noobs. Hand up if you're a noob at Node. So we've got two experts. Three experts.
Is there only noob and expert? Is there no middle ground?
Well,
No.
If you know more than a noob, then you seem an expert as a noob. So I'm going to try and say what is Node, why would you use Node, and then maybe like a how in a coding session, try and show Node in action for a few simple cases. First thing is that Node is very lightweight. Basically it's a lightweight framework for running JavaScript on the server. It's basically just an exe. You just like drop an exe on the wherever you want to install it, and that's it. It's not like IIS or Apache or anything like that. You just really do just drop one executable in, and then that's what runs your Node application. It's mainly focused at I/O based applications, network and disk based stuff. It's very good at that due to its event driven architecture, which Tom will tell you about later. So basically Node's goal was to provide an easy way to build like highly networked applications in a very scalable way, and I'll try and show you why it's scalable. Yeah, that's the one. So, I don't know if you know, but Node runs on top of the V8, on top of Chrome's V8 JavaScript engine, which is a very fast implementation of JavaScript. Uses all the latest compiler technology, so it's really quite quick, and you compare it to like PHP or anything like that, and it's just as, you know, it's pretty quick. It's quicker than that. It's quicker than obviously Ruby and things. So that's good. So this is the Node stack. You've got your Node standard library, which I'll be sort of demonstrating a little bit, and then that's written in JavaScript. All that is JavaScript stuff, and then the Node everything below it is all written in C, so that's why it's quite quick. So you've got your Node bindings to V8 and libuv, and it's libuv which does all the eventing stuff. V8 engine powers most of it. And then not shown on here, you've got all the modules which are sort of an extension of the JavaScript bit. There's literally thousands of modules that you can use. It's not just server-side JavaScript. It's not just the ability to run websites. It is just like a command line. You can run a desktop app using Node if you want to write it, a command line app, just like you can with like Perl and Python and Ruby and that sort of stuff. So you don't have to write a website. You could just write like a curl command line utility using Node if you want. Okay. So this guy, Ryan Dahl, wrote Node in 2009, mainly because he wanted to write a web application that was using a lot of push web, web stuff, and he didn't really find anything that really fit the bill. He wanted it to be really scalable. I think he was writing something similar to Gmail client, which is always using lots of JavaScript to talk back to the server and many connections all at once. And he didn't really find anything that fit the bill, so he decided to write his own, as you do. The main benefit being the really fast super fast networking and fast disk I/O. So I'm going to try and give an example, classic example. If you read anything about Node, you get this example, which is like a fast food example. So traditional web servers, you get one guy, so this guy here, you walk up to the counter and you ask him for a Big Mac or whatever your preference is, and he takes your order, and then he walks around the back and he gets the ingredients off the shelf and he puts it on the cooker and starts cooking it, flipping that burger and getting the cheese and sticking it on. You're stood there waiting, and the guy behind you's stood there waiting, and fixes all that up, brings it to you, gives it you, then you pay him, and then you're done, and you walk off, and the next guy comes and says, I want a Big Mac as well, and he does the same thing again. So this is sort of the traditional way of doing it, with Apache and IIS. You get this thread pool, and each thread has an amount of allocated resources to it. And it's scaled by adding more and more worker threads. So you get more and more people saying, yeah, and in order to serve 10 people, I need 10 employees. In order to serve 100 people, I need 100 employees. So you just keep on throwing resources at this thing, and that's how you scale. But obviously there's a limit to that, and eventually you get this queue, which everyone knows happens. And this is typically how .NET, Java, Ruby, PHP, all these sorts of systems, that's how they work. But most restaurants aren't like that. You get someone who takes the orders, and someone who prepares the food, and someone who sources the ingredients, and all these different people doing it. So that way you can serve one guy at the front end can serve many people, or many requests. And that's sort of how you can think of how an event-driven architecture works, like Node, and that you get all these different people or different requests all coming in. And it's non-blocking, so the waiter takes one order and then says, okay, give that order to the chef, and oi chef, tell me when you're done, and I'll give that thing back to the customer when you're done. That way I can take lots of orders, and the chef can do lots of stuff all at the same time, and as soon as it's done it says, yeah, and that's when it gets handed back. So it's like an event-driven, non-blocking architecture. That's what Node is all about. So that's the sort of way you can think of it. But why? Because it was a cool picture that I found. So why? Why do we want a single-threaded application? It sounds like a bit of a downside, one thread, serving thousands of requests all at once. Sounds, contradictory, it sounds right. So it actually makes sense when you think of it in an event manner. In that you're not waiting for things, therefore you can do. I mean, that's what most CPUs do anyway. They switch, lots of switching and whatnot. If you want to use many cores on one processor, you just run many instances of Node. So each instance of Node is a standalone thing. You can scale using many cores of one processor if you want to do that. But I think you need to have quite a lot of nodes. You need to do that because it serves quite a lot of stuff. Concurrency in traditional apps is actually quite difficult to do. As we all know, you always get these little niggly bugs that you'll never find, and they'll just break things. So by not having concurrency, you don't have the problem of what happens if these two threads both share this same object state at the same time. So you don't have to worry about that. you're sort of getting around that concurrency is difficult to do problem by never being able to do concurrency. And it forces you into a distributed architecture straight away. So because I know I'm only going to have, I have to, in order for me to scale, I have to make sure that my app runs on one core of one processor. I can't scale any other way than to make it stateless. Right? It has to be that way for it to work. So from day one, you're forced into this mindset of how the app is going to scale in the long run. You don't have that problem 3 or 4 months down the line when you realise your app no longer scales. And you can share code from the client to the server. So you could write some validators which run on your business logic on the server. But those same classes could be run in your front end. So you get very responsive front end, but that same validation is happening for security purposes on your back end. So you don't need to write that validation in JavaScript and C# and doubling your effort. You can just write it once and use it in both places. The final reason why is because it's new, and it's strange in a way that it's taken off in how it has. I mean, it's only a few years old, and it's massive, and the community is really, really big community, and lots of modules. It's very easy to create a module and push it into the repository, and you can pretty much find modules that will do anything you want. I think I saw a stat that there's more modules now than there are Ruby gems, and even I think it was Python. I think it's even bigger. It's almost bigger than all the Python modules and whatnot as well. So it's really exploded, which is quite strange for a brand new language, which obviously shows there's a lot of interest. Okay, I'm going to try and show you some code now and see what happens.
Is this a thing that those people they do like emulators for Mario games and stuff? I've seen all written in Node or something weird like that. Is that the
There's all
same thing? Or
sorts.
is it?
Although I'm not sure you'd write an emulator for Mario in Node. Maybe you would. Tell me at the end.
All right.
Okay, I'm just gonna start from scratch, and I'm gonna basically just show you some bits and pieces. If there's any questions, obviously shout out, and if you see I've done a typo or something, just let me know. It'll speed things up. Okay. Okay. So let's. Just because it's habit, I always do that. So that we need to do it. So Node has got what you call a REPL, a read event print loop, which lets you interactively use it. So you can just like type things in and see the results. So it lets you sort of debug your commands as you're writing stuff. You can jump into this, and the same thing as Ruby's got. If you've ever used that, or Python's got one as well. So let's just do something really simple, just to show that it can do everything. So it is a full. It is entirely. You could write your server in this if you wanted. You don't have to use a file and put all your stuff in the file, you could write it straight into the repo.
Well, you could fire up a server from the...
You could fire up a
laptop.
server from that command prompt. So basically there's some globals you can use. So I just typed in process, and this is all the stuff to do with the actual process. And you can actually get at all sorts of different stuff about your computer. So it's not just JavaScript, as you can see, because you can't get at all this stuff from a browser. Standard JavaScript doesn't have this sort of stuff. So it gives you can do a lot more in Node than you can on the browser. Obviously path and all that sort of stuff. You can get to quite a lot of stuff. For example, I can see the process of that, and if we just have a quick look, this, I don't remember what it was, 6136. So you've got access to all that stuff. Really quite simply as well. It's all at your fingertips. And okay, so I'll show you how you read. Just reading a file as well. So let's just create a file. So this is now showing here that you need a callback to make this work. So I'm using filesystem.readFile and telling it what I want to read, and then this function that I'm passing in is the callback, the event that's going to happen when the file system reads the file and tells me that the file has been read. Now in here you would put all your logic for actually handling that error and that data, but I don't really want to do all that, so I'm just going to just write it straight out. And it's quite small. Have I done that right?
One more, maybe a semicolon. And also, yeah, no. FS isn't defined. Do you need to like require it or something?
No, that means I've done something wrong. That means I've typed something wrong. Because you don't need. I'll show you. You don't need to do that. So the FS is there. Okay. So then and that's it. So foobar 56. So it's read it and printed it out using that evented type architecture. So it's file system read file does the read, and when it's finished reading it, it calls the function callback that I've created and logs that data to the console.
And it doesn't block until it's read that data. Is what you're saying, right?
Yeah, yeah.
So
but because it's all on the command line, it's difficult
okay.
to show that. I'll show that in a minute. Okay. So if I try doing something a little bit more complicated. So I'm just going to create real simple JavaScript app. It's not actually going to be a server yet. So, can people guess what that's going to do? So, bar, 2 seconds, then foo. It's pretty obvious what that's going to do. But, you notice that it, so I was running a server using nodeserver.js, but it's just exited. And it's exited, but it didn't exit whilst it was waiting for the timeout to happen. Exited once all the events that were inside Node had been finished. So Node keeps a track of all the different events that's going on. And I can sort of show that by sticking another. So you can see that now Node knows that something is waiting. So every time a set interval occurs, there's something else happening. So this will never exit in this instance. And this is the same as what happens when you set up a server. When the server's running, Node knows not to exit because there's something listening for something. Unless that server blows up, in which case then your application will exit because there's not, because the server's actually broken. So then it'll exit. So with the set timeout, that's not a block. As you can see, that's, if we scroll back up to the top here, that's not a blocking thing that's going on. You know, it's waiting 2 seconds and then between printing bar and foo. All the while it's printing bang. So that again is showing the non-blocking event nature of Node. That multiple things, whilst they're not technically going on at the same time, there's this event callback thing going on where, you know, something is waiting and then it'll tell Node that some event has occurred that it needs to take some action on. So let's write a real simple web server. So this is how you bring in modules using the require. And require is just another global variable that you've got access to. So again, you're creating a server, and then you're going to tell the server what you want it to do using a callback. So this is the thing which is going to get called every time a web request comes into this server. So I'm going to just spit out something, and then you've got to tell the server what you want it to listen on.
You need to define that res as a parameter to that function.
Yep, yeah. Someone's paying attention. You have to pass in the request and the response to that. We appreciate that.
Oh, no joke, I don't understand.
Lead. It's lead speak.
Oh, guys.
Okay, let's see what that does. So it says it's on, and it's still printing bang out, but it's at the same time as that, it's listening for incoming connections. So I'll just go here and do a curl maybe. Curl. So it's listening for stuff, and we'll jump back. Did I tell it to print some? Oh no, I didn't tell it to console write anything. So let's see the headers are. So it's using the latest version of HTTP by default, and it's got connection, keep alive, and it's chunked. So keep alive allows HTTP, the connection itself, to receive many connections from the client and responses without having to reconnect and go through that whole connection handshake thing all the time. Chunked allows me to write partial responses back to the client. So I can write a small amount of information and send it to the client, maybe saying, you know, I'm working on something, and then when it's finished, I'll send the rest of the response back. So that way, you can get around the page looking like it's not doing anything all the time. So I can sort of simulate that. Okay, so let's change this. And I'll just get rid of that. So, thank you. So I'm going to write hello, and then I'm going to simulate some sort of slow stuff. So this might be a database call or something like that. I'm just using a timeout, so we're going to do all that stuff. So, let's see. So it says 6 seconds. Let's see. Okay. So it's sitting there, potentially querying a database or whatever you want, and then it finishes all the response and sends you that back. So the client got something, something else happened, then the client got the rest of it. So you can imagine how that might work in an AJAX situation. You fire an AJAX request at the server, you get back a, yes, I've got it, I'm processing something, and then you get the rest. I should have said turn your mobiles off. So I'd say that's irrational. Okay, and that set timeout wasn't asleep, so I'm going to demo that with, I've got this thing called Apache Bench, which is a benchmarking tool by Apache, all people, and allows you to try out different concurrency stuff and fire many requests at the server in a really quite a lightweight way. So I'm going to fire 10 requests of a concurrency of 10, and let's see if that works. Be patient. So hopefully this will take 6 seconds. So let's see. So let's have a look. So complete request 10. Time taken for the test is just over 6 seconds, which is sort of what you'd expect, even though this is an event. You know, this is a single thread, all serving all them 10 all at once. So there's 10 requests in the server at that point in time. So let's try changing this. See what happens. So I'm firing 1,000 requests to the server. Maybe I should print something out whilst we're doing it. Just gonna spit something out so we know it's actually doing something and I'm not just doing some trickery. So let's right, done that. Okay, let's fire all them, jump back there, and it's now you've got 1,000 yays. Yeah. So this took 7.2 seconds to serve 1,000 concurrent requests, which isn't too bad.
Oh, the Bangalore team were trying to call in.
They can get the video. Well, you can do it on your phone.
No, John's texting me.
Trying to ring into this meeting.
We did tell them, yeah, because it was supposed to be for them too.
I don't know how to do that.
Okay.
We've got the video. That's why I videoed it.
Alright, fair enough. Carry on.
Okay, so whilst you were chatting away, I just fired 10,000 requests. Took 20 seconds, there was no failures. So, you know, it's quite scalable. I mean, admittedly, all it's doing is hello world with a little timeout. But there are 10,000 open connections to the server from Apache Bench to Node. I've not done any comparison with IAS that does that, but I need to get around to doing some benchmarking between the two so I can properly see the difference. I know IAS is quite good, but I'm not sure exactly how good it's going to be compared. So it'd be interesting to do it.
So what happened when 10,000 requests on the server? Does it fire 10,000 threads? There's one thread.
One thread, serving out of 10,000. Yeah. Which doesn't sound right. But it is. So that's how it works.
No, but how is it doing that? Are you going to tell us, or have you already told us? I don't know.
How does it well, you can obviously, Node's open source, so you could dig into it if you like, work out exactly how it does it. But it's all based on the evented I/O. You know, the way that it works means that no one thread is hogging all the resources. No one particular request is hogging all the resources. It's just keeping them all on one thread using that evented I/O. If you want a technical how, I think you're going to have to read about it. It's beyond my expertise.
So in most cases, do you want to offload all your sort of heavy lifting stuff into a different into a different thread? Is it not different threads, or into an event, right? So
Yeah.
let's say you want to do some really complex calculations, it's going to take forever and ever.
Well,
You
complex
want
calculations aren't good. Your node is not good at that sort of thing. So things like, it's very good at I/O bound stuff. If something is I/O bound, i.e. it's reading a database, which can take a long time, or it's calling Viper, which can take a long time, or it's it's doing things which are external to Node, but take a long time. So reading the file system takes a long time in processor time. The time that it actually takes to read a file from disk and get that back into the app, in processor time, cycle time, that's actually a really long time. So you don't want the processor to be waiting for the disk to give you back the data. You want to do something else. You don't want to be waiting whilst you talk to another service, whilst you could be doing something else. So it's all about these events and sending events off, and then just saying, right, I know I've sent that, tell me when it comes back, and I'll then do some work on that thing that's just gone off and come back.
Yeah. I think that's a good explanation, and I think maybe a naive way of explaining it is if you have 10,000 requests in IIS, essentially at any point CPU is processing one request and then does an expensive swap from that request to another request, and then an expensive swap from that request to another request. Node doesn't have that expensive swap. It's just processing. It's just single threaded, right? So it's just processing one request. So it's not wasting any time. Even in IIS, you're just processing one request at a time, one core processing one thing. It's just not obvious to you that a lot of time is wasted swapping.
Yeah. So I was going to do a little demo of a long-running blocking process, but I don't think there's time, so I'm going to skip that and go straight to an Express application. So Express is a module which is sort of the MVC of the Node world. It's very popular for writing web applications in an MVC style. So I was gonna try writing a really quick Express application and see how that goes. Because we've still got a quarter of an hour, but let's see. Oops. Is it not?
You did it in demo, one folder up.
Okay. So first thing is I need to get the Express module. And then use it to get that. So this is where now you say, I want to set up a get or a post or a delete or whatever verb you want the app to listen to.
Quick question, what is Express? Sorry.
Express is an MVC application module which allows you to write quickly and easy, MVC style web application. So this is sort of a really basic implementation. So you have to pass in a request and response. So app.get takes an anonymous function, or a function, in this case it's just an anonymous function, which is going to listen to the request and give back a response. So that's what the request and response is. So I just spit something out. So that's as simple as you can get. Yeah, so here it says, cannot find module express. So some modules are global and some modules aren't. There's a very small number that are, and express isn't one. So I don't think I've got network in here, so this might be a bit difficult. So use the Node Package Manager, that's what npm is, to download modules. So you just say npm install express, and then it'll go off and it'll try and get what you're asking for from the repository. And it'll, in this instance, when I'm getting express, it'll get like 20 or 30 calls to things, all different things, and bring them down and stick them into a folder. Because I've got no network, which is a problem, I'm going to have to, this is one I did earlier,
Nice.
luckily. So this node modules. So node modules, this is what would be downloaded. It would all go down into this place called node modules, and in this case I just asked for express, so it'd bring down all the stuff that express needs to run. So that's not going to work, so don't have internet. But now, because I've now got express, I just got it from somewhere else instead of downloading it. Ah! So now it's listening, and if I do a curl,
So you changed the port to 1.
did I?
Oh yeah.
Oh, no.
Not so.
Not so clever now, are you? Okay. So the real basic web server, and you'd write, each of these apt gets is the same as your root. So when you set up roots in .NET and MVC, that's the same sort of thing as these apt gets. So, and then you put these little function blocks. In this case it's an anonymous function, but when you're writing a bigger app, you'd actually start creating classes and basically the controller and the action, and that's what these functions are. That's the action that's going to take place. So you put that function in a separate file which sort of represents all the functionality for the home page, and so that's how you do that. Cool. So I'm just going to show you that that's what you do by sticking another. So this one's going to respond to foo, that one's going to respond to the home page. So that one. So there, basically, that's the same thing as your controller and actions. I was going to show you as well Jade, which is like very similar to Razor. It's how it's the way that you can create views, and basically it's a view engine in the same way as Razor's a view engine. The syntax looks similar. It's like much more like Haml than Razor syntax, but it's very similar stuff. So everything I've been showing you is the callback, idiomatic Node. There's another way of doing Node, which is a streaming style, which is another. If you start using Node a lot, you'll see lots of streams everywhere. So these requests and responses are just streams, and you can pipe things between streams. So I've got another demo, but we're running out of time, so I'm not going to write it. I'm just going to copy it from somewhere I've done before. If I can find it. Okay, so I'll just show you this. So this is a reverse proxy written in basically one line. So
Snap.
I'll show you it working first, I guess. So you can see how I'm using ExpertHR as the domain that I want to reverse proxy to. So, is it running? Yep. So let's. Yeah, it's all local. Oh, damn it. Maybe I will not show you this thing. Oh yeah. Damn.
You'll get an error message streamed off instead, won't you?
Okay, so that's. Oh, I don't have time. Okay, so that's. If you can run that, I'll run that afterwards if people want to look at it. But basically, that is really quite impressive when you see it. And what it's doing is it's getting the request that you ask for. So I'm going to ask for the home page, and it's going to pipe that request through to this request module. And the request module is going to go off to the internet and request that URL. And when it gets that URL, it's going to get the data from that URL, and that's what that is. So that's now a stream which represents the data from that request, and then you pipe that to the response. And so basically you're piping the thing which is coming back from experthr.com straight into your response and streaming it straight back to the browser. And first time I tried it, I didn't quite believe what it was doing, because you see the whole web page in its entirety, along with its assets and its JavaScript and everything, just because of how the browser plus this works. You'll have to pester me later to see it. And if you're watching on video later, you're going to have to type this in and try it.
There's a portable network open if you want to do Wi-Fi.
And there's a network cable under the table. I'm not sure what that is.
Well, I'll just finish. If I've got time at the end, I'll do that. But we've only got 5 minutes, and I want to finish this. So, okay. So let's go back here. Can you do that? Okay, so who's using it at the moment? These are big names who are using Node for various different things. Don't know how many of them are actually using them for their main website, but they're all using them for various different things. Joint are the main sponsors of Node. If you go on the Node websites, they're the ones who look after it and run it, and they've got an IDE in the cloud written in Node for writing JavaScript, which that's pretty amazing as well. So there's plenty of people using it out there. So comes to Tom's point. What's Node not good at and it's not good at processor-hungry tasks and computational stuff. So anything which is going to block the processor. So if you're trying to calculate pi to the thousandth decimal place or something, you're going to be the processor will be doing that whilst everyone else is saying, "Hoi, hoi, I want some of your time too." But there's only one thread, and if that thread's processing pi, no one else is going to do anything. So processor-hungry stuff isn't a good fit for Node. Same sort of thing with text manipulation stuff. If you've got big amounts of text and you want to be doing some sort of regular expressions and whatnot against it, that's all going to block the processor whilst that's going on. So because it's single-threaded, you don't want to do computationally hungry things unless you want to start spinning up multiple instances of Node and running them on many cores. That way you can do it, but that's not really a great way of scaling. That's it. So that's Node in an hour. If there's any other questions? I'll try. Well, look at this. Can you leave that on, Tim, a sec? I'm just gonna. So if you want to stay, I'll try and get this demo working. But if you want to go, then you can. But I'm gonna try.
Is your network still?
It's still here. It's called Portable.
Portable.
Isn't the RBI Wi-Fi system?
Sorry?
The RBI.
Yeah, it wasn't working for me this morning. So.
Me neither. Maybe it's your login. I was using your login. Should I use yours?
Mine works.
Is it on?
Yeah, can you not find it?
Okay. It looks like it's working. Okay. So let's see.
Can you bring it up on the main screen as well?
Oh.
Please.
Sorry. Why isn't that turned off? Okay. So let's try macroing and see if this works. So that is the ExpertHR website.
That was pretty quick.
If I
Just the first page or like the whole thing?
just the home page, but if I
Shut up.
We don't allow people to download the code.
Just checking. Oh, you guys are rubbish. I'm not asking anything else.
so I've just hit our Node website on localhost 1337, and that's downloaded the entire contents of the homepage
We
using a
can't even,
reverse
it doesn't
proxy.
even load that between the browser. How does it go? No, really, it's magical. Maybe it's nothing happens when you click on stuff.
So you can see that it's requesting all these things because well, they're all going to localhost, except the external things, which are obviously not. But you know, the whole thing is driven by just this one line reverse proxy, which when I first found this, I did it.
The rest of the site.
Yeah, it should all work.
HTTPS module.
Well, as soon as the thing is, let's see what happens. It should do. I don't see why it wouldn't. So basically, the site, as if it was on my laptop, but it's clearly not on my laptop. So it's just an interesting use case. So I was thinking we could use this for Viper, for the Viper simulation of the delays. You just put a delay.
Yeah, actually, I think
sort
at
of
that time, I think we had a debate, Fiddler, I think. I wish we had used this, but we ended up using Fiddler. But I think we can redo it. But yeah, so yeah, with 3 lines of code, we can simulate the Viper delay. Yeah.
Any questions?
It took them a lot more lines of code to make it that slow.
Well, we're not allowed to mention Viper now that you're on the team. You should just come here.
I'll gauge with it,
X-Nail.
okay.
Yeah.
No, that's fine.
Thank you. Thank you, everybody.
Yeah, thanks a lot.